You've probably heard a lot about OpenClaw over the last month or so, and of course all the derivatives like nanoclaw and PicoClaw, and wonder what all the hype is about. Well, in this video I want to explain what PicoClaw is and how PicoClaw compares to OpenClaw. We'll then look at creating a single skill with absolutely no coding, and then something a little bit more advanced, do something useful. So to start off, PicoClaw is an open source AI agent project written in the Go language. It's designed to be very lightweight and portable. The project describes itself as an ultra lightweight personal AI assistant that can run on very modest hardware. It emphasises low memory use, about 10 megabytes, fast startup times, and it's compiled down to a single binary to deploy, so very easy to get started with. The important idea is that PicoClaw is not just a chatbot, it's what's known as an agent loop. What that means is it can receive a request, decide which tools to use, run those tools, inspect the results, and continue until it has no answer. It's also often referred to as an AI orchestrator. It doesn't actually contain an AI itself. So to explain that a bit more, rather than the end user interacting with a large language model like OpenAI or Gemini, PicoClaw does this using their APIs. So you make a request to OpenClaw using some kind of recipe. It sends requests in JSON format to the large language model, which also responds in JSON. The PicoClaw agent then decides whether or not the request is satisfied. If it's not, it continues until it gets an answer. The important thing about, or one of the important things about this, is that context is retained during the loop, and the agent can even retain information in its memory and session stores for later user requests. So instead of you losing all of your context of your work each time you go into OpenAI, that's all retained. Instead of only generating text, PicoClaw can also interact with files, shell commands, web tools, and other capabilities that are exposed to it in the underlying operating system. Of course, that also comes with a risk, so you have to be careful where and how you run it and what access you give it to resources. So how does all this tie into OpenClaw? Well, OpenClaw was one of the original AI orchestrators and has gained a lot of momentum over the last couple of months. PicoClaw isn't a fork of OpenClaw. The project was actually built from scratch in, as I said, the Go language, which means it's compiled down to a binary. But the two projects are close, and PicoClaw has even added a migration command for OpenClaw workspaces because the structures are very similar. The big difference is really just the design philosophy. OpenClaw is generally heavier, more fully featured ecosystem. You may have heard of people running it on Mac Minis, and it's been a boon for Mac Mini sales over the last few months. PicoClaw is stripped down, lightweight, and doing low resource environments. It can even run on a $10 microcontroller, and the original authors actually produce a microcontroller that can run OpenClaw. So that means it can be used in embedded environments and give AI capabilities to those environments. So you can imagine microcontrollers about a factory monitoring various states, that information being fed into a large language model and the results compiled and perhaps alerts sent, that kind of thing. Skills. If you've seen a PicoClaw skill before, it looks surprisingly simple. Sometimes it's just a skill.md file with instructions in it, and that makes it all seem a little bit mysterious about what's going on. So you ask, if it's just a markdown file with a text description, what's actually doing the work? So let's have a look at an example. We're going to have a look at this IP skill, and it lives in the workspace skills IP directory, and it's called skill.md. So the aim of this skill is to get the public IP address of the computer. So that's what we say inside the skill. To get the public IP address, run curl -s and then go to this URL and use return JSON as the answer. So roughly what's happening step by step. When I type in /use IP, I'm prompting PicoClaw that I want to use the IP skill. So what I type in next will use that skill. So I type in, what is my public IP? And here's a rough sequence of what's going on. PicoClaw sends the large language model a structured request containing system instructions, the context, the conversation history we've had previously in the available tools. The model says that it wants to inspect the IP skill, so it tells PicoClaw to read the skill.md file. After reading the skill, the large language model decides which tool to use. In this case, it will choose, because it's in the skill file, to execute the curl command on that URL. PicoClaw goes away and executes that command. The large language model can't execute that command itself, and even if it did, it would be getting its own public IP address. We want to know the IP address that where PicoClaw is running. So PicoClaw executes command, captures the output. It sends the output back to the model, and the model, using the instructions in the skill.md file, sends back a user-friendly response. Your public IP address is this, and it appears to be located in Lyon, France. The model, the key architecture is the model, the LLM, decides what to do. PicoClaw executes it through its registered tools in hopefully a sandbox safe environment. The PicoClaw skills can feel both powerful and a bit odd. A normal plugin is usually rigid. You define a function, the framework calls the function, the result comes back, that's it. PicoClaw skills are more like instructions for the LLM. PicoClaw provides the tools and execution environment. The LLM reads the skills and decides how to use those tools. It's also sometimes why skills can go wrong. They're a bit vague, instructions can be unclear, the model can misinterpret them, and this is something that I saw originally with this skill. I didn't tell the model not to overwrite the skill.md file, so it was actually originally, before I put that in, as you can see in the skill.md file, the result came back from the model and the skill.md file got overwritten by PicoClaw. So this raises some questions. Wouldn't plain coding be simpler and more efficient? And in many cases that's the case. If all you want is a public IP address, you can just write a little shell script or a Python script to get you that information, and that's going to be a lot. It's going to give you a guaranteed result, deterministic result, rather than involving a large language model in a loop. So for fixed, well-defined tasks, traditional coding is usually the better engineering choice. Where PicoClaw becomes interesting is when the workflow is not fixed. So when the agent has to choose between tools, read instructions dynamically, inspect outputs, retry, or chain steps together. So as you can see, what PicoClaw is doing is orchestrating and reasoning, not just raw execution. So what we saw was a very simple skill, but as you see, there was no coding involved. It's a little bit of the holy grail for managers, is to be able to produce useful things without actually having to understand and write code. Well, there they have it. But sometimes you actually don't have tools available in the underlying platform that let you do the task you want to do. And what I wanted to do was build a skill, do something slightly more advanced, and build a skill that could analyze stock prices. And I'm going to do this using Python and a tool called or a package called Yahoo Query, which lets you get that stock information from Yahoo. And the script I built, which I'll show you here, it pulls down historical share price data and calculates the 1-day return, 5-day return, how far the share is from the 20-day moving average, and the volume. And then it gives a simple signal about whether the stock is moving upwards, downwards, etc. So what the AI can answer is, what are these stocks doing right now? And it can say, well, all the stocks, or the stocks you're analysing are above the 20-day average. This stock is an outlier, it's well above. The volume is medium or light, so you can say, well, there's not too much conviction in this analysis. So I wrote that, and I'm running it here, and as you can see, it gives this output, but it's fairly thin on the ground, and we're in the context actually of a military operation, in the Straits of Hormuz, which has greatly affected oil prices. So just seeing this information, I think, oh, the stocks are on the up, I should be buying, buying, buying. But what's the actual geopolitical context? So I wrote a second skill, market skill, which goes out onto, decided to use in the end Google News, but you could use another news feed, and it basically filters for oil, geopolitics, inflation to get some idea of drivers. So it basically tells me what's happening in the world. So it's beginning to get quite powerful. So we're tying in the facts, the raw data, with the feeling to understand why stocks are moving in a certain direction and whether these are long-term trends or short-term effects of the geopolitical situation. So stock data, what happened, market context, what might explain it. And you'll see here I'm running this, and you can see it just gives me a bit of JSON output saying what the news headlines are. That's really all I need. So they're two separate skills, briefing and market skills. And where the LLM will become very useful is actually analysing the two sets of data and giving a summary, a brief report. And I thought a bit about how I'd structure this, and I decided I'd leave the two existing skills, and then I'm writing this stock explainer, a third skill. So it's got its own skills.md file, but it doesn't have any underlying Python files to either pull the share data or the market data, because we've already got that information. So what it does, pulls the stock information for the tickers I'm interested in, gets the market context today, and then asks the AI to analyse and merge the results into one answer. And it basically gives you stocks move like this, possibly or probably because of this macro event. The kind of answer we get is all stocks are above the 20-day moving average, and the macro context points to oil volatility and geopolitical developments. The move appears to be macro driven and not company specific. Some important design decisions that were involved, although it was a bit of luck more than anything else, because I thought my briefing skill was going to be sufficient. Keep skills simple and focused, one for data, one for context in this case. Let Python do the calculations, don't rely on the LLM to do that. They can often fantasize about things as well, but let LLM analyze the results and give you an explanation. And get the AI to combine the results, analyze them as a whole, not just give you a summary. So this is really a proof of concept. I wouldn't use this for doing your stock analysis each day, but it gives you an idea of the kind of things that are possible. And just to reiterate what I said, you use the scripts, Python scripts or whatever, to fetch data, pass results, do any calculations you need for anything that's deterministic where things have to be right. Use PicoClaw and the LLM for deciding when to run those scripts, combining the outputs, and analysing and explaining the results and giving it in a nice readable form. And what I could do with PicoClaw is set up a cron job and use that cron job to do an analysis every morning. So and then send it by Messenger, WhatsApp or Telegram or whatever, or even email, so that every morning I get a nice little analysis based on my own data of the stock tickers that I'm interested in.